And we are live in 3, 2, 1, go. So what's the plan for today? Let's get our Vulkan test solution open in Visual Studio. And let's see. What happened the last time I've been working on this project? So I have focused on getting the render target on screen, right? Let me clean things up as we go, since we don't need this function anymore. Get this thing compiled and up and running, and see what is the current stage of the project. First time compiling. It should take a little bit more than usual. We already know that. But in the meantime, let's get to the render target, right? So one of the things that wasn't working and I have lost a lot of time on is the fact that, first of all, I was using, despite creating a lot of stuff in this command, not the command, I mean the render target. Why does it even need any internet connection? Probably because of the render dock. Okay, so the thing that I've got wrong is that during the creation of the render target, I've also set up the whole pipeline that needs to draw on this specific render target, right? But in the application class, in the draw up class, what I was doing is that I was passing to the filler command class the data from the main render buffer, the main render target, the swap chain. So I guess even though it was still working, it wasn't quite right. So I fixed that, but the real problem here was that I was calling the render target to texture, which had an unpredictable behavior, which is mostly because I still have some gray area in the image memory barrier usage, and the fact is that it probably had a wrong source access mask and specifically an old layout, or maybe it was just the wrong source stage mask. But Anyway, that led to a wrong behavior. Instead, what I did is that when I fixed when I've used the right data, the right pipeline, all I did is to set the final layout of the render pass to be sampled, to be ready to be sampled in the Fragment Shader. So the right layout for the color attachment is shader read only optimal, which is why it is now working. Anyway, let's move on, and first of all, let me clean up some of the junk that I've made in order to debug, which is this if statement here, which I don't really need anymore. Okay, great. We now have a filler command which would be more practical to get the clear command directly from the create instead of relying on the definition before the calling of the create. Method. Okay, and let's just specify that here. It's vec3 color clear color. And here as well. Where we can also say that this equals to a very bright red as a default value. And what it does here is that we don't need to store that value anymore. Instead, we are going to pass it to the command buffer directly. Cool. And that's it. We can now compile and expect the inner rectangle to be green and the outer space to be a bright red, as it is now. Cool. Very cool. That is very cool. However, we are getting something in here. So there is a duplicate binding number. We are in the descriptor set layout, create info, duplicate binding numbers, set layout binding. Where does that even happen? Maybe in the render target. Okay, that's funny. I didn't notice this earlier. Duplicate binding number, we get to set layout binding. Descriptor set layout binding. Right, yeah, because we are still setting 4 of them. And probably the rest gets allocated by default. And that gets also through the binding count. This gets fixed by now. Okay. Cool. Let's move on to something more specific, which is the creation of the brush sample command. Which in turns should be quite similar to what we already have in the command rendered screen. So what we can do is that we can just come over here and copy the file shamelessly. Command render stroke. Cool. It renamed both of them. Nice, very nice feature of you Windows. I remember trying to use that in earlier updates, and it was a mess. Turns out they fixed the behavior. Good. Let me bring those into the project and rename the class according to its function. Stroke. Let's go to the CPP file and also rename the included file, the class name, and we are good to go. Same things apply. Same things apply, yeah, sure. Should we create yeah, at this point I'm not even sure if I should create many of these commands or use them many times. It's probably best to spawn them all and then queue them to the render queue. That's what Vulkan has been made for, right? Is the stream going as expected? Yeah, seems to be healthy. Not as bad as it was yesterday. Why did I even close that? Cool. So let's get to work. We need from here to customize the behavior of the stroke. And do we need a clear command? So there is quite a lot of work to do here, and it also involves changing how the pipeline works for the render target, because we are not interested anymore in just getting something on screen. We also want to do some blending, and that's why we will need to re-enable these two descriptor binding, because they are linked to the other shader we will be using instead of the fill one. So the first thing to do is to go back and use the right data and the right pipeline. The right pipeline, which will also get this to specify a little more data. Uniform and combined. So, right. Find descriptor set. Actually, what I could be doing is to split the descriptor set in two, which is one defines the finer data of each stroke sample, which is just the location, pressure settings, and that kind of stuff, while other things which are which have a different life are the image samplers, right? Because they will be used over and over again for each sample that will be thrown onto the canvas. But that is something that we can do later. We don't want to start optimizing things which will ultimately just make it more complicated. It's not that much complicated, because we only need to define another descriptor set somewhere else, and then bind it here, I guess. Bind descriptor set. I mean, it clearly says descriptor sets. Descriptor right. Can I do that? Like, I don't want to. Might be even thinking this wrong. Yeah. I don't know, that might just be too much thinking for such a simple thing, that it may not even have such a great impact as I'm thinking about. So we'll just leave it as it is for now. Descriptors layout. Yeah, this is pretty much where that gets passed, right? Anyway, yeah, so we've got everything that we need to specify as a base. But that was the data that is needed in the other pipeline. This pipeline is instead a little different, and it has 4 binding slots, which takes into account the texture background, which will be again the frame buffer view, and the texture brush, as well as the color uniform. So the first thing that we need to do is to go up here and vertex UBO. Where did the other UBO ended up? I may have lost it. There was another structure that that I defined a few days ago, and I was using it at the beginning, but I may have deleted it. So it might just be faster if I come over here and define it again, which is a fragment UBO, which only defines a vec3, or is it vec3 or 4? It's a vec3. So that is a vec3 color, and we will be defining it in here as well. Fragment UBO. Let's say this is the vertex UBO, and this is gonna be the fragment UBO. So we create both of them, and they will be set somewhere up. Next we create the command that will be used, a descriptor based on what we have said earlier, which comprises 4 values instead of 2, and 2 of them are basically, so this is the vertex UBO, then we have the background How did I even call that? Then we've got, which is the MVP. MVP background stroke background. Text background. Text stroke, also known as brush, and the fragment UBO, which is also known as the color of the brush. Right. Now we need to also specify those more extensively, and we start by defining the fragment buffer that will be associated with the second and third slot, right? Let's keep the same order, which will make it easier. Fragment buffer info, here it is, fragment buffer info, and that points to the fragment UBO buffer at offset 0, whole size, descriptor, image info, frame buffer, and then the brush. Whoops. Time to rename things. Frame buffer view. Followed by the brush view. So this is the frame buffer view, and this will point to the brush view. Cool, everything almost in place. Brush points to this descriptor set. Clear color. We might not even need a clear color because we won't be clearing the frame buffer. Okay, time to update. Back on the prototype here. All right. Cool. We've got all we need to at least draw a single brush stroke on here. What we want to do now is to come over here and get the command render stroke. Let's begin with a single one. Where did this get defined while the other one is not? Why is that? Render target utils. This is weird. For some reason, the render screen has been defined. Alright, that is because it's been defined in the app, which uses it to draw on screen. So let me include that and create it here. Pretty much a copy of what we had previously. Except that is gonna get the frame buffer view followed by the texture view. So this is gonna be render target dot frame buffer view. And rename that to the correct instance. Let's define the vertex data as well. As the fragment UBO. Let it be a very bright blue. And now we should be able to draw that. That stroke command on the canvas. First we test if this compiles. Everything looks good from the C++ point of view. And now we're gonna check if there's anything wrong, which we are getting. So we get descriptor set bound at set 0 following validation. Descriptor in binding to is being used in draw but has never been updated via update descriptor set or similar call. Okay, why did this happen? 0, 1, 2, 3. We have an update descriptor set. Are we getting the right pipeline? 0, 1, 2, 3. Seems like we are getting everything that we need. So the pipeline, does it point to the frame buffer data? Render target description, render target, render pass, pipeline, everything points to, sorry, wrong line, everything points to the render target data. But it is still complaining that something is wrong. And that actually happens. Oh. So that happened on the wrong line actually. We don't care about that. And let's try again. It was complaining about the other thing. Looks like we are getting something. I didn't expect to work on the first trial. But now cannot use VK image. Read only that doesn't match the previous known layout. Color attachment. Descriptor set not updated. What's happening here? Okay, fair enough. So we are getting this problem because we need to make a transition. Which is something that we already did back in the first day of trying out color blending, which I believe is somewhere. It should be somewhere commented. It should be commented out at this point. But I'm not seeing it. Maybe in the to screen, not on target texture, not here. Maybe we can have a look at the log. Let's see if we can do this from here. Changes. Branches. Master. So how do I have a look? At the history. View history. Right. Okay. So what can I do from here? Dynamic tends to wrap under the screen. Enable blending. So it must be here. With enable blending, we should have a transition. We should have a memory barrier somewhere. Maybe it wasn't that far in the history. Let's see if we can get it from here. And I don't want to diff it. Just show me what's in it. Let's see if I can spot that transition. And still no transition happening. Set to dynamic state. Let's see. Must be here somewhere. Not yet. So there is an introduction of new shader. Still getting maybe I just ignored it. But I'm pretty sure it was somewhere. Which was the place where I copied or not. Anyway, maybe back in the day. See, in the fragment shader that was too of a simple fragment. Add the texture. Let me get that fragment shader history. Show log. So what happened to this fragment shader during the time? Can I see a preview? What the hell? What's the preview panel? View patch. So what happened here in the fragment? It got more complicated, but still not sampling from the frame buffer. Here is still very simple. We've got the first sampling here. And at this point, I may have missed the image barrier, but maybe I just deleted it. So thanks, but I might just create it from scratch. So what we need to do is when the rendering happens down here, when we submit the render stroke, it may happen that the frame buffer view is, wait, what about this? descriptor image info, shader read only optimal. Can I, for example, say that this is going to be used so what is the layout of it? Shader read only or color attachment? What if it's both of them? VK descriptor image info. VK descriptor image info. Descriptor sets. VK descriptor image info. VK descriptor image info. What is in here? We got the image view and the image layout. Is the layout of the image accessible from view will be in at the time this descriptor is accessed. Is used in descriptor updates. Sampled image storage, combined image sampler, and tab input attachment. So what is the valid usage? Okay. So at the time that the descriptor is accessed, it is in shader read only optimal. Right. But we need to specify an image barrier as we did here. Actually, two image barriers. After the begin, let's set these two image barriers which will in turn do the following. So they will be pointing to the frame buffer view. No, actually we need the frame buffer image as well, which we didn't get anywhere else. So const vk unique image reference of the frame buffer image or img. Okay, copy that, literally copy it, and update the prototype of the function as well as its usage in the main class. So render target dot frame buffer image, as simple as that. Let's go back to the image barrier and set it over here. Good. We've got two image barriers. And we need to define their way of working. Let's start with the first image barrier, which will happen at the top of the pipe. So the source, which we will be expecting that to be, is in the fragment shader. Or let's say the top of the pipe, I don't know. And what we need it to be is in the fragment shader. And we need to move from shader read only optimal to wait. Let's get back to the fragment shader. Okay. We don't want to. We don't want to create anything that has a weird behavior. And what we may need is to define It doesn't match the previous known color attachment. So it is in color attachment. And what we need to do is to bring that to move the layout, right? Okay, so it is a color attachment, and we need to move to a fragment to shader read only optimal. That will happen. That will likely happen somewhere. I don't know. This is always an unknown. Not sure how to use it properly. And this will move the axis to fragment to shader read, is it? Color attachment read or shader read, memory read. To shader read. Yeah, that seems like the right one. We need to be read by the shader, and it first was flag bits color attachment right. Then from color attachment right, actually from read to color attachment right, and from shader read only to color attachment optimal, from the fragment shader to the color attachment output. Okay, let's see if this makes any sense. We still getting, yeah, we are getting plenty of errors. Layout shader read only. So the error is that the command buffer sub resource to be in color attachment optimal. Instead, current layout is shader read only optimal. Okay, stop this. Okay, so the submit command buffer expect level 0 to be in VK image layer color attachment optimal. It's in shader read only, and it looks like the second pipeline barrier didn't work as expected. The image is the same, it needs it to be color attachment optimal, aspect mask 01. Pipeline barrier. Okay. Yeah, there is an error in the definition of the pipeline. So first of all, that is wrong. It's not supported by, so the source mask, stage mask 01. The source access member of each element must only include flags that are supported. Okay. Cannot use VK with specific VK that doesn't match previous known color attachment. So we are definitely getting the right image. So let me move the data we don't care about up there, which is not going to change. One image. So we need the old layout is color attachment. Let's see. What is the message again? Cannot use VK image, which is the same image we are talking about here. Cannot use VK image layer with specified layout VK image layout shader read only. That doesn't match the previous known color attachment optimal. Okay. Let's do one thing and move the whole thing up in here, so we only get the messages once. And again, why did it get so long? So is not supported, so the access mask 100, the access mask 100 is what is 100? Hex is 256. So color attachment right. Is not supported by source stage mask 01. Source stage mask 01. Okay, so the source was color attachment output, and this may fix things up. Let's see. We're getting more errors. Yes, we do indeed, because when drawing cannot use that image with specific layout. Read only that doesn't match the previous known color attachment optimal. The source access mask. Let's say we don't know about it, and is, let's move this at the top of the pipe. We are still not moving that image. Layout, pipeline, image barrier. I believe that is the image. That must be the one. Brush view, brush, FB view, okay. maybe it depends on something else. So the next error is core validation draw state descriptor not set not updated. That descriptor set bound as set 0. Image layout specified vk update descriptor set maybe that is the problem. It's not shader only, it's a color attachment optimal. That was the problem here. Let's see if at least that error goes away. Which it does, but we are getting an even longer one. What? This is so long. Set fail, right update, validation for descriptor set. Binding 1 failed. Attempt to write updated to combine image sample. Descriptor failed due to descriptor update. VK descriptor combine is being updated with invalid layout. VK color attachment for image. Image layout general. What? Okay. At the time of creation, we probably need the render target. Image layout general. What if it's just general, or even better, an unknown, undefined? Let's do a general then. Let's see if this is compatible with it is. But at the time of the draw, it complains Well, I think I'm getting hungry. So let's stop this stream here and get back to it later. With new exciting Vulkan stuff. Bye. Later.